Welcome to Learn Power BI Step by Step for beginners. And this first chapter is like of 22 chapters we have in this. And this is like a 1 hour of video which will, wherein we'll first try to understand what is Power BI. We will download and install Power BI. We will go through some very, very important component like table chart, line chart, bar chart, stack chart, column chart. We will also talk about some important concept like analytics, creating calculated column, measure column, slicer, and so many other things. But before we start with anything, let us first try to understand what exactly is Power BI, what is the use of Power BI. Power BI is a data visualization tool. So basically it can take in such kind of data and convert it into a visual format. So for example, it can take in data like this and convert it into a bar chart, or must be it can convert it into a pie chart, or must be it can convert it into a funnel graph, right? So basically it takes in such kind of data and converts it into a visual format, right? Now the strong point as well as the weak point of humans is, they understand only visuals. So for example, if I give someone this data, it is very difficult to conclude something. But if I give something like this, he can just look at this data and say that, okay, the most sales which I have done is to Mr. David, right? So basically when you give something in a visual format, it is very easy to do analysis and conclude things. So Power BI is a data visualization tool and a business intelligence tool. Now installing and getting Power BI is pretty simple. So just go on Google and search for Power BI download, and you can hunt for the first two links which are specifically pointing towards Microsoft.com, and you can go and you can download this Microsoft Power BI desktop. And once you download this setup, right, and if you just run the setup, the installation is pretty simple. You have to just click on next, 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 and Power BI will get installed into your system. Once the Power BI is successfully installed, you should see such kind of a thing in your program file called as the Power BI desktop. In case if you are not able to install, please send me a mail at questpond@questpond.com. I'll be more than happy to help you. So once you click on this, such kind of designer opens. And if you see this designer, right, at this moment, you will see a lot of things. But the whole designer is divided basically into 3 sections. So you can see that there is a left bar out here, which has a couple of icons. You can see the top bar, which has lots of functionalities, and you can see the right bar, which is of the visualization. So basically we have 3 bars which are out here, and most of the time we'll be working on these 3 bars. And the middle area is where you go and you design your report or you design your visualization. Now, before we start any visualization inside Power BI, the first thing is we need to go and load some data. So you can see here in this lab 1, I have provided a very simple customer CSV file. CSV stands for comma separated values, which has customer code, customer name, country, age, product, amount, year, and so on. So we will use this CSV file to load some data inside Power BI, and we will try to understand how Power BI functions. Now, in case if you want this CSV file, it is uploaded in the video tutorial itself. In case you don't get the CSV file, please feel free to mail me at questpond@questpond.com, and I'm more than happy to help you. So in order to import this CSV file inside this Power BI, we need to go and click on this get data, and we need to click on this text CSV, and we need to go and select our CSV file. So I'm going to go and select our CSV file. What it does is, before it goes and it loads everything into Power BI inside your studio, it gives you a preview saying that is this how your data looks like? So it actually gives you a very simple preview. And in case you feel that no, this is not comma separated file, this is space separated, or this is semicolon separated, you can feel free to go and change the delimiter. Feel free to edit. You can see that there is a simple edit as well. So if you want to go and change some small data, that is also allowed here. But at this moment I will not change anything, so I'm going to go and just say load. So there it is. It is loading this whole data inside my Power BI desktop studio. Now, if your data is loaded properly, the first thing what you would see out here is you will see the fields of your CSV file. So you can see at the right hand side, you can see all the fields of your CSV file, which is an indication that the data has been loaded properly. And you can go and you can click on this left hand side bar on this data. You can see I have moved my mouse out here. I can zoom it as well, right? So you can see here this second icon, you can go and you can click, right? So if you click on that icon, you can see all your data out there, which is an indication that the data has been loaded into your system. This left side bar is very important. So this icon is to see the data. This icon is to see the relationships. So for example, if you have 3-4 CSV files and if you want to go and connect them, for example, at this moment I have the customer CSV file. Let us say I have an address CSV file. So I would like to go and make some joins between them, right? Some relationships. Then this tab is important. And this tab is where you will go and you will design your Power BI visualization, right? So this is for visualization, this is for the data, and this is for the model, right? So this left hand side bar you will be frequently visiting. Now inserting a visualization inside a Power BI report is a 3-step process. The first thing is you need to go ahead and select the visualization component. So for example, you can see there are lots of visualization component on the right hand side tab, right? So the first thing is let us go ahead and select one visualization component. For now, let us keep it simple by selecting a table, just a table, right? So for now, let's not select bar charts and pie charts. Let us select a simple table. So as soon as I click on this, you can see that at the right hand side on the designer, he has put up the visualization component. So the first step is you need to insert the visualization component on the designer. The second step is on this visualization component, you will go and you will apply the fields. So select the visualization component. It is very important to select the visualization component. For example, at this moment, the visualization component is not selected. Now the visualization component is selected. So ensure that you have selected the visualization component and then let us start selecting the fields. So let us take the customer name. So as soon as I click on the customer name, you can see that it has applied the data to the table. Then I select must be the age, right? And then I select so on, you know, so you can see now that things have got applied out here. The next step is, so the first one is you will take the visualization component. The second one is you will go ahead and you will start selecting the fields. And the third one is you will configure the fields. For example, you can see here, this first one is the visualization. The second one is the selection of the fields. And this third tab out here is to configure the individual fields. For example, at this moment, if you see my age, right, this age field out here, it is actually doing a sum. For example, if you look at Ashish over here, this Ashish is showing, is actually displaying 70. Why? Because there are two entries of Ashish. So if you see here, if you go and if you see the text file, where is my text file? Okay, or we can see the data as well. So if I go here to the data and if I select, I'll unselect all and let us select Ashish. So you can see this is Ashish out here. This Ashish has two entries. So basically the customer code is 1006. So it is the same customer, but the age is 35 and 35, right? So what it has done out here is he has taken this Ashish and he has actually made a sum. So where it is, there it is. So he has actually made 35 plus 35, 70, which we don't want it, right? So I would like to go and select this and say that on this age, right, don't apply a summation. So I'm going to go and select here and say, no, this is not a sum, right? So I'll say do not summarize, right? Now I should see two entry of Ashish over here. So this is Ashish of 35 age, and somewhere down below again, I should see Ashish somewhere. So I should see two entries of Ashish. So one is this 35 out here. Another one should be somewhere down below, right? Oh, that is sorted. So where did the other Ashish go, right? So we'll figure out that, right? We'll figure out that. But the point here is at this moment, he is not doing a sum on the customer, on the age, right? So select the component and start selecting the field. So I'm going to go and select the amount as well. Must be, you know, this again, I'm not really looking at sum directly, right? So I'm going to go and remove this. Also, I would like to go and take the country. I would like to take the product. I would like to go and take the year. So step one, you will go ahead, and you will select the visualization component. Step 2, you will select the fields and then you will configure the fields as per your need, right? You can also see that as soon as he sees the date field, he has actually gone ahead here and split the year, the quarter, the month and the day, so that you can see the data in a more proper way, right? Now, in case you do not follow this process, means for example, in case you do not select the visualization, and if you directly start selecting the field, for example, you can see here at this moment, I have not selected any visualization component, right? This is selected, this is not selected, right? This is selected, this is not selected. So if I go and start selecting the field, for example, if I select customer name, what it does is it actually then takes up the table visualization by default and starts doing things. So you can see here, because I did not choose any visualization component, by default, he has taken the table visualization component, right? So for now, we don't need this. I'm going to go and delete it, right? Now, all of this visualization file, this project file is stored with the extension PBIX, right? So you can see here, I'm trying to store this file out here. So let us give a name here, lab1.pbix. So by default, the extension is Power BI, Power BI file, PBIX. So that is the extension. So I'm going to go and save it. This file is also available as a download in the video. So in the video, you will find two things. One is the data file and one is the PBIX file. So now let us take a bar graph. So you can see now this is the table. So now you can see from the visualization, I'm taking a bar chart. So there it is. You can see the bar chart out here. So in this bar chart, what I want to do is I want to go and show data product wise. So if you see our file, if you see our data at this moment, we also have product, right? So select all. So if you see at this moment, we have different kinds of product. We have shoes, we have shirt, we have cap and so on, right? So I want to go and see here like product wise, what is the total sales made, right? So I'll go and select this. So I want to see the product and I want to see, the amount. And at this moment, I want the amount to be a summation, right? So there it is. So you can see here, this is the shoes, this is the value, this is the shirt, this is the value, right? So, so this is the bar chart. Also, let us go ahead and take some other things. For example, let us take, you can see that I have taken the line chart, right? So if you see at this moment in our data, we have the year 2016, 2019, 2018. So I want to go and plot, show this graph, where as per the year, how much is the sale, right? So I can now go and take the year and I can now go and take the amount. So there it is. You can see it is showing me a line graph, of how the sales trend is, right? Now, if you look at this right side tab here, it is divided into three sections. First one is visualization. Visualization means, what component you want to drop of the visual component. This one is the fields, what fields you want to select on the visualization component. And you can see this third tab out here, which has three more things inside it. So first one, this one actually configures the field. So if you remember, we had said that summarize and don't summarize. So that's what this field is. And you can see this next thing here called as format. This format, what it does is it actually helps you to format the visualization component. For example, if I want to go and change the background color, so I can say that, okay, I want to go and change the background color to something like this, right? Or I want to go and change the foreground color, right? So I can go ahead and also change the foreground color. So basically, so I can say, okay, data color. So I'll say data colors, I want it to be more of a black, right? So you can see here this second thing out here. So one is, this axis, basically in the axis, the actual fields on the axis, what you want. The second one is the format, what kind of coloring you want, background you want, right? For instance, one of the things, which I always keep on here is the data labels. For example, when I keep this data labels on, you can see it is showing me here the actual values. If you see here also, when I select on this and if I select the data labels, it is saying me, okay, this value is 8,850, this is 8,400 and so on, right? So this is to configure the axis and the fields. This is to configure the formats. And this one here is for analytics. For example, now, over here, I want to see that, from all of these three products, which of the products, how many of the products are below 9,000 and how many of the products are above 9,000 visually, right? So what I can do is I can go here and I can add a trend line. So you can see here I can add a constant line, or I can add, so at this moment, let us add a constant line and let us make it more solid. You can see this small thing out here, solid. Let's also make this as dark black so that we can see it. There it is, right? And let's not make it transparent. Let's make it really dark, right? So I want to say here that, okay, tell me how many of my values are above 9,000, right? So you can see that, okay, the caps what we have sold is below the 9,000 line, and the shirts and the shoes are above the 9,000 line. In the same way, we can also add here. So I can go here and say, okay, let us add. You can see now, depending on the visualization component, when I was over here, he just gave me a constant line option, right? But when I go here, he's actually giving me more analytical option here, like trend line and so on, right? So if you see here in this components, we have more lines, right? But at this moment, let us do constant line. And in the later part of the class, I will talk about the other lines as well. So I'll say here, okay, add line, and I want to know that how many of my things are above 8,500 mark and how many of the things are below the 8,500 mark, right? So you can see here it's showing me saying that 2016 and 2018 you were above this trend line, but in 2017 and 2019 you are below this trend line, right? So basically this is for axis configuration, this is for formatting, and this is for analytics. Now, before we move ahead to chapter 8, I would like to give a piece of advice out here. When you are looking job in the Power BI market, or when you look at a Power BI professional, only doing Power BI will not suffice. With Power BI, people also ask for SQL Server, which is an RDBMS. People also ask for MSBI, so they ask for SSIS, SSAS, and SSRS. People also ask for Tableau and some other things. So my suggestion is that with Power BI, these 2-3 things are also essential. So now here is a small gift from my side. So what you can do is, if you can go and if you can share this YouTube video on your Facebook wall or on your Twitter wall or on your LinkedIn wall, and if you can send me an email saying that I have shared your YouTube video, I will give you 3 hours of video free. So 1 hour from SQL Server, 2nd hour from MSBI, and the 3rd hour from Tableau, right? So if you can go and share this video on Facebook, Twitter, or LinkedIn and send us an email at questpond@questpond.com, I will ensure that you get 3 hours of videos for free to start with these 3 things. So now let us proceed with chapter 8. Also, one of the cool features of Power BI is auto filtering. For example, if I go and select shoes here, so you can see that this is the shoes bar graph. If I go and select on this shoes, what will happen is automatically the other 2 visualization components will only show you the shoes data. So at this moment, if you see, I have selected the component, so you can see it is showing all the data. You can see the small refresh out there. But if I go and say shoes, you can see at the right hand side, everything has been filtered to shoes. And also you can see over here in our, in the graph out here is also only showing the shoes data. If I say shirts, it's only showing the shirts data. If I say cap, it's only showing the cap data. If I go and select on the visualization component, it then goes and shows me all the data. And this is for all the visualization components. Means, for example, if I go here and if I select Akash, you can see now automatically the other visualization components have changed, right? But if I go and select again the main component back, right? So if I go and select again the main, I can go and select this. So I have to go and select this one, right? So you can see now, if once I am on the visualization component, again, I can see everything, right? So basically, one of the great features of this Power BI is that there is a kind of an auto filtering, and by using the auto filtering, you can see the data accordingly. Now, definitely when you complete your visualization, you want to go and send this whole thing as a PDF format or with, in some other format to the end user, right? So you can see that they have given an export to PDF option. So you can go and you can export to PDF, and you can email this report to the end user as well. Now, one of the requirements, which always comes from the end user is that to add a new column, and this column value depends on another column. Means, for example, now you can see that we have a column here called as amount, but let's say that the end user says that can you go and create one more column as the discounted amount, and this discounted amount will be amount minus 10% or minus 10, right? So if I see 250 here, I want to see 240. If I see 300 here, I want to see 290. For that, we need to go and we need to create a new column. So this column here, this column is also called as a calculated column. Why calculated column? Because it depends on other columns for calculation. So I'm going to go and click on new column here. The time you click on new column, you will see that he has added that into your lab 1 data set, right? And it over here, you can see that he has put up a small formula window, which is like Excel. So I will say that this column name is discounted amount, and this amount should be calculated from the lab data set minus 10. Now you can see here this lab 1 data is nothing but this one, the lab 1 data, the actual data set which we imported, and this is the field name, right? And now this whole thing, what you see out here is termed as DAX formulas or DAX expression, data analysis expression, right? So I'm going to go and press enter. Once I press enter, you can see that in your lab 1, he has put a column here called as discounted amount. And if I select on this, so for example, let us go ahead here and let us try to add this discounted amount. So you can see out here, this is 250, it is showing as 240. This is 300, it is showing as 290. So this calculated column out here is nothing but it is a column whose values will be calculated from the existing columns of the data set. If you see now, we have added this discounted amount, and this discounted amount is a column. And in the same way, we have one more concept called as measure. Now column is more at a row level. So for example, you want to take this individual row value and you want to do some calculation on it, right? So it is a column. A measure is having aggregated values like sum, average, count, right? So let us go ahead and add a new measure here. So I'm going to go and add a new measure. You can add a new measure or a calculated column from here, or you can add it from here also. You can see here, new measure, new column, right? So I'm going to go and add a new measure, and you can see again, it opens up the DAX formula editor out here, new measure. So there it is. Okay. So now this new measure, what we will do is we will say average sales. So at this moment we have sum of the sales. We are trying to find the average sales. So now if you go ahead and if you try to reference the table, for example, if you try to reference lab 1, you can't. Why? Because this is a measure and it does not allow you to reference the row level values. So you need to go and put some aggregation like sum, count, or average I will put, and then only it allows you to reference the fields. So this itself says that a measure is more of an aggregated value, right? So I'm going to go and take the average of the lab amount. So this is average sales, and you can see that the average sales is right out here. So now what we'll do is let us go ahead and plot a graph, plot a kind of a bar graph where we can see the average sales versus the total, right? So there it is. So we can now plug in here the average, the amount. So once we plug in the amount, this is a sum. Now we will go and we'll plug in the average sales. You can see a small black arrow out here. We can go ahead and we can customize to see the values. So we can go ahead and say that show us the data labels. So you can see here 34,600 is the total, but you can see on average, you are making 346 per customer, right? So we have column, which is individual row level calculation, and we have measure, which is more of aggregated data. Normally, when you work with big reporting projects, right, you would end up with a lot of reports, and fitting all the reports in one screen is very difficult, right? So you can see here, Power BI has given a concept of page. So for example, you can see down below, I can say that this is a dashboard page, right? And I can click on this plus sign and I can say, okay, this is a page, where I will show the bar charts, must be I can say this is the report for inventory, right? And then I can say this is report for accounting. So basically, if you want to really organize big reporting projects, it is better to organize them in such kind of pages, rather than trying to fit everything in one page, right? So this will actually logically make more sense to the end user as well. Okay. Now let us go ahead and try to cover the first line of visualization component. So you can see in the first line, we have like 6 components out here. So we have the stacked bar, we have the clustered bar, and we have the percentage stack bar. So these first two are they belong to the family of stacked bar charts. The second one belongs to the family of clustered bar charts, and the last two belongs to the percentage stacked bar chart, right? So let us see what each one of them is. And what I will do is I will name this page as bar charts. So this will cover almost all the bar charts which are there in Power BI. So let us start with the first one. I think first one we have already covered, but I will still go ahead and put it out here. So this is a stacked bar chart, right? So let us see what exactly is a stacked bar chart. So I'll go and take an amount and I will take the product. So if you see at this moment, it is showing me, the product wise amount. But now let us say if I go and take country as well, right? So if I go and take country as well, you can see now what it did, what it has done is on the same bar, he has represented the countries as well. So for example, you can see here, it says that this is shoes, but from this, this black region here indicates Nepal, this pink region here indicates USA, and the blue region here indicates India, right? So basically a stacked bar chart, what it does is on the same bar, he tries to represent multiple things, right? So this one here is a stacked bar chart, right? And if you see here, this is a stacked column chart. So both of them are, the same things. Only thing is that one shows it vertically and the other shows it horizontally. So both of them actually mean the same thing, right? But some of the people like to see in this way, or some of the people would like to see in this way. So depending on your visual preference, you can select one of them. So that is a stacked bar chart. So on the same bar, multiple dimensions or multiple data can be seen, right? Now let's go ahead and select the second family, clustered bar chart. So I'm going to go and click on clustered bar chart. So I'm going to go and put it out here, right? Now in the clustered bar chart, if you see, let's go and take the same thing. We will take the amount, we will take the country, and we will take the product. Now you can see here, the clustered bar chart does not stack on the same bar, but it actually takes up, it creates different bars. So you can see here, it says, okay, this is for India, and for India, this is the product, the caps total, this is the shirts total, this is, the shoes total, and so on. So over here on the same bar, multiple things are represented, and over here, we have multiple bars for multiple dimensions, right? Again, like if you see the second thing, again is vertical. So this is just vertical and this is just horizontal, right? So both of the things mean the same thing. So this is the clustered bar chart, and this one is the stacked bar chart, right? You can see we have one more family here, the last one. They belong to the percentage stacked bar chart. So basically this is same like the bar chart, but it will show things in percentage rather than showing things in absolute amount, right? So let me go here and select, let's say the country, and let us say again the product, and again the amount, right? So you can see here that, and let's try to make it vertical. So here it is. You can see now both of the things almost probably look same, right? Now but the difference is that this will actually show in percentage. Now please note, you can see here that things are looking different. Why? Because down below it has countries and this has the products, right? So let me go and switch that. So I'm going to go here and let me move, so here it is. So I'm going to go and move this to the value, right? And this one I will say move, must be, I can just go and delete it for now. So let's go ahead and delete. So we'll see later on how to, so I'm going to go and take this, right? So I will take, let's say now the amount, where is the amount? It's amount, and then I will take the product, right? And then I will take the country, right? So if you see now, you must be seeing the data is almost same, right? But here you can see that this is in percentage. Okay, so now the things are right. Okay, previously what was happening is, there was a shuffling between X and Y axis. So that's why they were not looking same, but now they are looking approximately same, but you can see that there is some difference in the area out here. So this is a percentage. So if you go and if you see the data label, so if I go to format and let me put the data labels out here. So I'll just make it on. So you can see this is percentage, but this is absolute values. So if you see here, this one here is absolute values. So if I go and put the data label over here, this is, so you can see this is showing like 4,700, 4,600 approximately, and this is saying 55%, right? So this left one here is a stacked bar chart, but this one here is a stacked percentage bar chart, right? So this is all the family of bar charts, the first line out here. Now, one of the most important thing in Power BI is to understand that how Power BI looks at plotting the graph. For example, when you are seeing this graph here as a simple lame person, you think that this is an x-axis and this is an y-axis. So on the y-axis we have the amount, and on the x-axis we have the countries, right? And then on this x-axis itself, the coloring is done by the coloring is indicated for the products, right? But Power BI names this x and y axis very differently. So you can see here there is a separate this on this field. When you click, right, there is something called as axis. When you say this axis out here means this x-axis. So if you want to go and see the countries on the x-axis like this, you should ensure that the field is out here. Then there is something called as legend. This legend means, basically what you want to see here at the top. So you can see the products are seen here at the top, right? And then you have the amount, and the amount is normally on the y-axis. Yes, definitely. If it is if you try to make it like horizontal like this, then yes, the things change. Here on the x-axis, the value has moved, right? So what I mean to say is, there is no x and y axis. So they have said that one is that there is an axis, this one, where you want to go and see, the data, the dimension names, and the other one is the legends, and then the value can be seen on the y and the x axis depending on the format of the chart, right? But what if you want to go and interchange them? For example, I want to put this x axis, this country as a legend, and the product legend on the x-axis, right? So for that, nothing, you have to go and I can remove from here. So I can go and remove this thing from here. So now I want to go and put the product on the axis. So you can see here what I'm doing. I've dragged the product and I'm putting on the axis. So you can see now the products are on the axis, and then I'll say, okay, the countries go to the legend and the value is the amount, right? So remember that we do not, here in Power BI, we do not think about X and Y axis, but we think about axis, we think about legends, and we think about value. A lot of times what happens is we want to only work on the certain aspect of the data. For example, if you see at this moment, all my reports are targeting all the countries. So I can see reports which is related to India, Nepal, US. If I go to the dashboard also, I can see India, Nepal, US, right? Everywhere. All of this data is actually taking everything from the data source. So this is our data and this is having everything, right? But I would like to go and say that no, for now, I want that all my reports should only target India and US. That's it. So I don't want to target Nepal, or must be I want to only target data which is related to India and Nepal, and I want to exclude US, right? So what you can do is, at the top level, you can go and you can apply a very kind of a global query and say that you want to exclude certain kind of data. So in other words, we have something here called as queries, edit queries. So I can go and I can edit a query out here, and I can say that, okay, I want to go and at this moment, I want to only concentrate on, so I don't want to select everything. I want to only select India and Nepal. That's it. So, so you can see now all my data is filtered as per India and Nepal, and I will say close and apply. So once you apply this, right, what happens is, all across your reports, where you're doing analysis, only now India and Nepal can be seen and US is excluded. You can see out here India and Nepal can be seen. So if I go to my dashboard now, I can see only data which is related to India and Nepal. For example, if I see my bar charts as well, you can see that I only see India and Nepal. So by using this edit queries, you can go and you can apply filter on a global level. So from the visualization components, we have covered the top line. So we have covered all the bar charts, right? Now you can see that we have lots of other visualization components out here, but let me start from the 4 components, which I use the most. So I work with Power BI a lot. On daily basis, I create lots of reports, right? But I would like to talk about the 4 components, 4 visualization components, which I use a lot from the down below, right? So let me start with the first one. The first one is the line chart. This is my favorite. So a line chart helps you to see the data using some time series. So for example, you want to see time-wise the stock market data, or must be you want to see the year-wise sales, right? So you can see that we have this year out here. So I'm going to go and pick this year, and I'm going to go and pick the amount, and I'm going to go and I want to see it country-wise, right? Or must be I want to see it product-wise, right? So you can see now it is showing me a line graph which is plotted against the year, right? So on the y-axis I can see the amount. Here I can see the year, and this is the plot as per the product, that is cap, shirts, and shoes, right? So a line graph is used, when you have some kind of a time data, a year, month, seconds, minutes, hours, and so on, right? So this is my first component, which I use a lot. The second one definitely is the pie chart, right? This pie chart component, it tells you that basically, from whatever things you have, how much percentage does everything form. For example, let us say that I want to go and say, okay, what is my total sales? So I'll say amount. So this is my total sales. So from this total sales, as per product, product wise, how much is the distribution? So you can see here, I can see, must be I can go country wise. Let's go country wise. So you can see that it's saying that the Nepal has more sales as per India, right? You can see at this moment, we are not seeing US. So I hope everybody knows why we are not seeing US, because in the edit queries, we have selected only India and Nepal, right? So I'm going to go and select US as well, right? And I'll say, okay, close and apply, right? So there it is. So now you can see here it is showing that the maximum sales is done by US, followed by Nepal, and then India, right? So again, the second favorite which I have here is my pie chart. The one more, component, which I use a lot and which really sprinkles my visualization is, which really sparks my visualization is basically the card. So this card is actually used to show a single value. For example, I want to just go ahead and show just one value. I want to highlight it somewhere. For example, the total sales. So it's just a single value out here saying that, okay, your total sales is 35K, right? So a card is normally used to show up a single value, flash up a single value, and you can highlight it, right? If you try to go and select some other value, for example, if you try to go and select discounted or something, it does not really work, right? So that is the card. And the last component, which can really excite your end user is the map, right? So if you have data which is related to geography, and if you want to show your visualization, on a map, then again this component becomes very useful. For example, at this moment we have country, right? So if I select country, it just highlights, on which countries the sales have happened. So you can see here the sales have happened in US, the sales have happened in India and in Nepal, right? If I go and select amount, so if I go and select an amount out here, it also displays, okay, the largest sales have happened in US, followed by Nepal and followed by India, right? So basically, again, this is my favorite component. A lot of times you want to really wow the user, right? So this is the map component, which I really use. So these are the 4 components, other than the bar charts, which I use a lot to just make my visualization better. One more important component here is the slicer component. So you can see this slicer component, which I've selected here. The slicer component helps you to filter or slice data. For example, I want to go and filter data as per the countries, right? So I can go and select on the country. So now you can see here, if I say India, I can see only India's data. If I say Nepal, I can see only Nepal's data. If you want to have this as multi checkbox, or if you want to select multiple options here in the country, what you can do is you can go to, so you can select the component and you can go to the format, and over here you can click on the items, on the selection controls, and you can say that show select all. So now with this, you can select all or you can do multi-select, right? And if you want to go and change these checkboxes to option buttons, that means only single select, then you can go and you can toggle this. So with this, you only have single select. So the slicer component helps you to filter data on all the visualization components. So when you click on this, it actually goes and filter data on all the visualization components. Now, when we talk about complicated scenarios, we will not have one table or one file, right? We will have multiple files. So we can have multiple files, and those files can have relationship between them. So for example, you can see that we have this customer data out here. It is possible that you can have such kind of a country file, right, which says that this product has been bought, this product has been manufactured by this vendor, and you would like to go and make a join between them. So when we talk about complicated scenarios, you can have such kind of scenarios, wherein you have multiple files or multiple tables or multiple data sets, and you would like to go and make a join between them, right? So let us see that how we can go and establish this relationship. So for that, first thing, let us go ahead and get the country file. So I'm going to go and say text CSV, and let us import the lab1 country. So if you see, once you import the country file, so there it is, you can see that we are trying to import and there are certain problems. I want that the first row is the column. So you can see that he has started putting his own name like column 1, column 2. I want that this first row should be taken as a column name. So we can go and we can click on edit, and let us go and use the Power Query Editor. You can see this Power Query Editor, which allows us to configure our query. So over here, we'll go and we will say use the first row as the headers. So let's do that. So now that looks good. The first row is actually our columns and then the data. So let us close and apply, and let us see if now we can get our data set right. So there it is. You can see now there is lab country. So this lab1 text file, the CSV file, this is the country data, and this is our customer data. And you can see, because we had this column name same, product and product, automatically he has figured out a relationship wherein he says that every one entry of this file will have multiple entries into this text file out here. So one entry of this product, will have multiple entries of products into the lab1 data. So you can see this 1 sign out here, and you can see the star sign out here. So this 1 indicates one record of this file has star multiple entries into the lab 1 data, right? In case, if this relationship was not there, for example, I'm going to go and delete it, then you need to go and create the relationship manually. For example, if this column name was product 1, then this automatic relationship won't have established, right? So now you can go and if you want to go and create a relationship, you can drag and drop. So again, let me show you can drag and drop this column and just place it out here. So if you do that, you can see now that this is 1 and this is many. So let us go and save this. So now we have 2 files and those 2 files have relationship of 1 to many. So now let us go to our visualization and let us see what do we see in the fields. So you can see now in the fields, you are seeing 2 data sets. So you can see out here, there are 2 data sets which are seen. One is lab 1 country and the other one is lab 1 data. So now I can go and select, let's say, the vendor from the lab country, right? And you can see here then because there is a join, it actually goes and joins the data. So you can see that this shoes is manufactured by vendor 3. If I go down below, you can see the shirt is manufactured by vendor 2. And if I go more down below, the cap is manufactured by vendor 1. So because, we had this relationship, automatically when you start pulling in data from both of these text files, the relationship is made automatically and the respective data is joined and shown. Now, if you want to go and share this report to some other person, so one of the ways is that you can create a PDF, but let us say if you want to share it online, then you need to go and publish it on the Office 365 Power BI server, right? So for that, you can go and you can create a Power BI free account. So for example, I already have a Power BI free account. So I'm going to go and start logging into it. So there it is. You can see sign in. In case you do not have an account, please, you can click on this try for free and you can start creating an account, right? So there it is. I'm logging to my existing account and I'm trying to publish this lab1.pbix file online. So you can see that already on the online, I have created something called as a my workspace. So there he's saying, do you want to publish it? I will say yes, let me publish it. And already this file was already published online. So he's saying, do you want to replace it? I'll say yes, I want to replace this. So there it is. You can see that it is publishing this report online so that I can share with the other users. If you want to go and see very quickly, where the report is, you can go and let's click on this open lab PBIX in Power BI online server. So I'm going to go and click on this. Now here also it is asking me for logging in. So I'm going to go and log in out here. Signed in. Yes, be signed in. So this is the online Power BI's admin panel, and there it is. You can see this report out here. So if you see here, this is the workspaces. So at this moment, this is my workspace. These are the workspaces what we have. And so if you see at this moment, these are the published reports, right? So this is my workspace. And in that, these are the following reports, which were uploaded. And this is lab 1. Now, what you can do is you can go and you can share the URL. So for example, I can go here and I can share. So you can see this small link out here called as share. There it is, share. I can go and I can share this report. Now remember that at this moment, I do not have a professional account. I do not have a paid account. So when I click on this, it says that, do you want to upgrade the account, right? But at the end of the day, this is very simple. When you say click share, it just creates a URL and the other user can access it. So if you want to go and share this report online, we need to go and use the publish option of Power BI. Now, the way really Power BI can grow multifolds is taking help from community, taking help from programmers outside, and taking help from vendors and so on, right? So if you see at this moment, Power BI has like 25 to 30 visualization components. But when you talk about custom projects, projects, at the end of the day, they want custom components, right? For example, I want a text search component here where I can go and I can do a simple text search, and I would like to apply the filters, right? So at this moment, we have a slicer, but this slicer is more of a checkbox. I want a free text box search, and I don't see this component here at this moment, right? So what I can do is I can take help from the marketplace. This marketplace is a place, wherein developers and vendors, external vendors can go and put their component, and people can import it, right? So for example, I can go and I can say that, okay, let's search for a free text search component, and there you can see that there is a text search component, text filter, right? So provides a search box, that can be used to filter all other visuals on your dashboard, right? So I'm going to go and add this, and let's see. So there it is. The visual was successfully imported into the project. So if you see now at the right hand side, so if you very quickly, if you notice at the right hand side, there is this visual component which is there, the text filter component, right? So let us go here and let us put this text filter component. So you can see this is the text filter component, right? So now let us try to go and see that if we can do a search, right? So I'm going to go and click on this, and let's try to customize this. So first thing, if you see here again, either it is the internal Power BI visualization component or the external, these three tabs is the way to customize that component, right? So you can see add a data field here. So I would like to do a search on the customer name. So you can see now it has pulled up a nice text box out here. So now let us say I go here and I say I want to search for John, right? So I can go here and say search for John, John, and I can hit on the search, and there it is. You can see the filter has been applied, right? I can remove this and I can hit on search again, and there it is. So I can go and search for Alok. So Alok, hit on search, and there it is. So basically this marketplace, helps developers, to take other third-party components and make their visualization better. One of the features, which I like about Power BI is the themes. So they are given a lot of themes, and also if you want, you can import more themes into Power BI. So before I send my report to the end user, so once I'm done with the report and it's time now to send the report to the end user or to publish the report online, the final thing I do is that I just go ahead and quickly check my themes, and I see that if some of these themes goes in sync with my end user's thought process. So you can see that this is a city park theme, a kind of a color blind safe, more lightweight, more dark like electric, right? So you can see that some of these themes out here can really make a difference once the end user sees your visualization report. Now before I end this session, I want to give you a golden tip. So basically I have demonstrated a lot of things out here. I showed you how to import data. I showed you how to use visualization. And when I was doing that, I was clicking all over the places, and must be, when I was clicking, it can confuse you, right? So this whole IDE can look very confusing for people who are new to Power BI. So here is how you can start with. So you can start first, when you start, right, just start anti-clockwise. So anti-clockwise means start from this first tab out here, start from this get data, go to this tab, and then move out here like this. So in other words, the first thing what you will do is, because you're new to Power BI, you will first get your CSV file. Second, you will try to do the designing, you will see the data, you will try to do the modeling, right? And then you will go to the visualization components. So you will click on the visualization components, you will pick up the fields, and then you will start customizing the visualization components from the perspective of formatting, from the perspective of access, from the perspective of analytics. So basically what I have seen is, in the initial stages, when I started learning Power BI, for the initial 5 or 6 demos, I used to start from here, go to this tab, right? So I used to visit these tabs, and then I used to visit the visualization tab, and then I used to go and select the fields, and then I used to go and do the customization on the components. So must be, if you are feeling very much confused at the first stage, what you can do is you can start in this way. First, get the data. Second, look at the data and get your designer on. Third, select your visualization component. Fourth, select your fields. And fifth, configure the formatting and the access. So that brings us to the end of lab 1. Now after this lab, I'm flashing some questions, which you can go through, you can revise them, you can understand that how much you understood in this topic. Now in lab 2, we will talk about how to connect Power BI with SQL Server. If you look at Power BI belongs to Microsoft. SQL Server belongs to Microsoft. So Power BI and SQL Server with MSBI forms a very nice ecosystem in terms of BI solution. So the next lab is how to connect Power BI with SQL Server. Thank you very much. When we talk about huge amount of data, CSV and Excel cannot handle the same because they are simple file systems. To handle large amount of data, you need a strong RDBMS like SQL Server, Oracle, and so on. Now, if you see, Power BI is owned by Microsoft, SQL Server is owned by Microsoft, it's the flagship RDBMS of Microsoft. So if you see in the industry around, SQL Server and Power BI is a very, very natural ecosystem, wherein Power BI is used for front-end visualization and SQL Server is the back-end. So in this lab 2, we will try to understand how Power BI can connect to SQL Server, and also we will look into various options like import and direct query. So the first thing is, let us go ahead and install SQL Server. So you can see that I have searched in Google SQL Server download, and that takes me to the first link of Microsoft. And if you go to this link out here, you can see that there are lots of flavors of SQL Server which you can install, like cloud and so on. I would suggest to install the developer edition. This developer edition is a full-featured free edition and specifically meant for learning and for knowing the features of SQL Server. So first go ahead and install the SQL Server developer edition. The second thing is, this is a Power BI class, so I won't be really concentrating on SQL Server, and I would really suggest you to go and watch this complete video series, which you can see I'm flashing on the screen, which has everything about SQL Server, so right from the basics, the installations, how to create tables, how to create database, and so on, right? At this moment in this video, my goal is to create data in SQL Server, to create some database and tables in SQL Server, and then show that thing into Power BI, right? So go ahead and download the SQL Server Developer Edition. Once you download SQL Server Developer Edition, you get something like the SQL Server Management Studio. So I'm going to go and click on that. So let us go ahead now here and create databases and tables. So there you can see it is opening. So let me connect. So I'm going to go and create a database called as Power BI. So we can say this is Power BI database, right? And inside this database, I'm going to go and create tables. So you can see right out here, Power BI database is seen. So if you see in our first lab, we already had this customer data. So you can see that we had this customer data, and also we had the vendor data which manufactures that product, right? So let us go ahead into this database and import both of these files. So I'm going to go to all tasks right out here, and I'll say import file, flat file. Remember that it is a CSV file. So I'm going to say import file out here. Again, I would suggest please go and see the SQL Server videos, but at this moment, let us quickly go and import this file and do our demo. So lab 1 data, the file to be imported. Let us now when this data will be imported, it will create a table inside this database, right? So let us give this name as TBL customer rather than saying lab 1 data, and I'll say next. So those are all the fields. Those are all the data types of the columns. I'll just leave it at this moment as it is, and we'll just say finish. So right out here, so you can see I'm going to go and hit refresh. You can see that I have the TBL customer with all the data, right? Great. Also, let us very quickly go and import in the same way our other file we had, which had country, right? So I'll just say TBL products. Next, and I'll say it's asking for some column names out here. We have to give some column names. Let's give some proper column names. So this is that is actually the product, and that is actually the vendor name, right? So I'll just say this is the product name and this is the vendor name. So very quickly, I'm just importing both of these files into our database. So there it is, TBL customer, TBL products, right? So now we have both the tables inside SQL Server. Now let us go ahead and open Power BI and let us see that how we can go and load this data into Power BI. So now you can see that I have opened the Power BI desktop. So now in order to go and import the data from SQL Server, again we have to do the same thing. We have to say go get data from where? SQL Server, right? And we will give the server name, right? So this is the server name at this moment. And the database is Power BI, right? And you can see now there are lots of options out here, but these two options are very important. For example, if I say import out here, import means the data will get imported into the Power BI file, into the Power BI itself. If I say direct query, that means the data will not get imported out here, but every time if he wants data, he will actually go to SQL Server, right? So at this moment, I will just say import. We don't have too much data, right? So I'm going to go and just say import out here. And once I say import, you can see that he says, okay, from this database, which tables you want to select. So I want to select the TBL customer and TBL products, both of them. And I will just say load it. So once you load the data, you will find the same kind of tables and fields created at the right hand side. So at the right hand side of Power BI, you can see right out here, these are the customers, the TBL customer, the TBL products, right? You can also see that this is your data. You can also see this is your model and so on, right? So I'm going to go here to this table out here, and I will say that this is customer name, this is product, right? Also, I'll go to the table out here and I will say that this is product name, vendor. So other things all remain same. So whatever visualization we have done by using the CSV file, all that visualization you can go and do with SQL Server right away here, right? In the initial section of the video, I said that when you are connecting to your SQL Server, it gives you two options, import and direct query. So let us go and explore both of these options in more detail. So you can see here, I'm connecting to the server, and remember that we had this Power BI database, right? So if you see in this window, I have opened up the Power BI report, using import, right? So if you remember, I said import means the data is taken from SQL Server and imported into the Power BI cache. And after that, even if SQL Server goes down or even if SQL Server does not exist, still you can go and preview your report. In case of direct query, Power BI will always need SQL Server to be on, right? So for example, now let us say this report, I am going to go and make it by using direct query. And this report which you see out here is actually using import. So if you see, this is direct query out here, I'll say load. So if you look at some of the differences, which are very logical, you will see out here is, for example, now this is the Power BI direct query. You can see that you do not see data sources out here. For example, look at this. This is import. So in import, you can see that there is data, right? So you can see that there is data. But if you go and see the direct query, we don't see the data tab out here because now the data will come from SQL Server, right? So in other words, when I go and click over here, amount and customer name and so on. So at this moment, it will go and it will fetch data from SQL Server. Okay. So if for some reason, if let us say our SQL Server goes down, so you can see here, I'm going to go and stop SQL Server. This would be very interesting to see here. So you can see now I'm stopping my SQL Server instance. So if you see now, my import will keep working. So, if you look at, this is my import here. This is my imported Power BI, right? Means this report is using the import feature, right? So if you see here now, I can still go here and prepare the reports, right? So I can still go and say that, okay, show me the amount product wise, right? So I can still see the report. I can still make reports because everything is coming from the cache, from the Power BI cache. But watch over here. Now, if I go and try to create a report here, for example, let us say I create a table, and if I try to take, the amount, right? So you can see here I've selected amount, and let us say if I try to select customer name, oh, where is the value coming from? Okay, this one I think is still in the cache. Let us take something else. Let us try to take the year as well. Look at this. So you can see here now this amount and customer name was already in the cache, so that's why it was able to show it. But look at it, when I selected year and product, you can see the small sign out here, which is actually going and trying to connect to SQL Server. And after some time, I should actually see some error here saying that I cannot connect to SQL Server. So you can see at the right hand side, oh, there it is. You can see cannot display visuals. If I go and see the details, it says that your SQL Server is not there. The instance is not running at this moment, right? So direct query means it will always need SQL Server, and import means the data will be imported into Power BI cache, and after that you do not need the SQL Server instance. Now you should use import only when your data size is small. So do not use import for large amount of records, because then your Power BI cache will not be able to handle it. It will be very slow, right? And direct query you will use when you have huge transaction tables, like must be millions of records, where you want to go and get data. So rather than importing those millions of records into Power BI cache and doing things, RDBMS has special powers of performance, of indexing, and so on. So you'd like to utilize that, right? So if your data size is small, use Power BI. If your data size is very huge, then you use direct query. So that brings us to the end of lab 2. Now in lab 3, we will run through some more visualization components like line chart, area chart, KPI, funnel graph, gauge, and so on. So lab 3 will be more about visualization components and some important tips and tricks which can make your visualization better. So thank you and happy learning. So welcome to lab 3, and lab 3 is all about 5 important components which I'm going to cover in this lab 3. One is a line graph, area graph, stacked area chart, KPI, that is key performance indicators, and funnel graph. So this is like a 15 minutes of video, and we will go into in depth into these 5 components. So let's get started. So let's first start with line chart, area chart, and stacked area chart. So let us go ahead and pull up this line chart out here, and let us go ahead and take product. Let's take the amount, and let's take the year, right? So I will drag and drop this product into the legend out here. So there you can see this is our line chart. In the same way, let me go ahead here and take the area chart, and let's do the same thing. Let's take the product and the year and the amount, right? So I'm going to go and take the amount, I'm going to go and take the product, I'm going to go and take the year, and we will drag the product into the legend, right? And in the same way, let us go ahead and take the stacked area chart. So let's put all of them out here, and let's see what is so different in each one of them, right? A line chart is very good to see the current trend. For example, you can see over here at the top we have cap, we have shirt, we have shoes. So the shirt is of a black legend, right? A black color. So if you see here, if you look at the shirt trend from 2016 to 2017 is in a downtrend, but from 2017 to 2018 it is in an uptrend, and from 2018 to 19 it is in a downtrend. If you look at cap, it is almost constant throughout the year, but there is a slight downtrend from 2018 to 2019. But the line chart is very good to see the current trend of a particular thing. But when you talk about who is contributing how much, it is very difficult to know from the line chart. And that's what exactly this area chart is all about. If you look at the area chart, let us say from in the first half, or almost in the first 2016 till the end of 2017, you can see that the cap sales has been dominating. So the cap product has been contributing the highest sales. If you look from 2018 to 2019, almost, from mid of 2017 to the mid of 2018, you can see that the shirts are contributing a lot. And you can see for the whole year from 2016 to 2017, everybody contributed. Look at this dark area out here. Everyone is contributing, right? So these small shades out here tell us that who is contributing how much, right? So when you talk about comparing between those data, then area chart becomes more useful. And one of the flavors of area chart is the stacked area chart. You can see down below we have the stacked area chart. Now you can see from this both of these graph at the top, it is very difficult to know who is contributing the most. For example, when you look at the graph, it looks obvious. Probably it looks obvious that the shirts are contributing a lot because it has shown the highest trend of its time, right? Of everyone compared to the other products. But if you actually go and if you make a total, you can see that's what exactly the stacked area chart is. It is nothing but it is like a complete total. So if you see out here, the shoes have been contributing throughout the area a lot, throughout the year a lot. So basically, a stacked area chart is nothing but it is like a complete sum of the running values throughout the year. So from here I can know that, okay, the most contribution till now from 2016 to 2019 has been from the shoes, followed from the shirt, and the last is the cap. So if you want to just see the current trend, then it is your normal line chart. If you want to see the comparison between the trends, who is contributing how much, then it is the area chart. And if you want to see overall throughout the year who has been contributing more or less, then it is the stacked area chart. One more important component in Power BI visualization is the gauge meter or the speedometer. So you can see that this is the gauge meter out here. So in this gauge meter or speedometer, you have a minimum value, you have a maximum value, you have the current value what is running, and how much you want to achieve. So by looking at a gauge meter, specifically for management people, they can come to know that what is their current trend, what is going on, right? So let us see how it works. For example, now at this moment, so you can see here when I drag and drop this component, you can see that there is a value, there is a minimum value, there is a maximum value, there is a target value which we want to achieve, right? So first thing, I'm going to go and drag and drop the amount which is my current value, right? So my current value is 26, and you can see that automatically he has just made it double by saying 52. So it's saying the maximum probably can be 52, right? So I'll do like this. I'll say that the maximum will be thrice of the current. So whatever is the current, I know the maximum would be thrice of it. So for that, let us go ahead and create a measure. So you can see that I'm creating a measure I covered in my first lecture. So I'll create a measure, and this measure will be the maximum value. So this maximum value will be the sum of the amount multiplied by 3. So it's thrice, right? So I'll say here the maximum value is now this one, all right? So you can see now the maximum value is 78K, right? And I would say that I want to achieve at least 1.5 times of this. So whatever is the current value, I want to achieve at least 1.5 more amount of the sales of that, right? So again, let us go ahead and create a measure. So I'm going to go and again create a measure, and this is, I'll say that what do we want to achieve, right? And achieve is equal to sum of the total amount multiplied by 1.3 or 2, whatever, right? Or 1.5, right? So I'll say that my target value which I want to achieve is this one, target value. So you can see there it is. So currently we are, the maximum we are looking at 78K. Currently we are trending on 26K. but at least we should try to achieve 39K. So that's what exactly the gauge meter does. When you talk about top management reporting, top management only wants to see very few things. For example, a typical top management person would like to probably just see two things: how much we want to achieve and how much we have achieved. And that's what exactly this graphical visualization component of Power BI comes to use, that is KPI. KPI means key performance indicators, important indicators, right? So you can see at the right hand side, we are seeing three fields out here. The first one is how much we want to achieve. So remember, I had created this achieve measure out here for the speedometer. So I'll use the same one. So I'll say, okay, this is my target and this is the current value. So you can see I'm dragging and dropping the amount, and in the trend axis, let us put the year. So you can see now he's saying that, okay, you want to achieve 375, and at this moment you have achieved only 250. You are 33% lagging, right? So this key performance indicator only concentrates on two things: how much you want to achieve and how much you have achieved. One of the other visualization component which is very useful, and when the need comes, this component just actually shines off, is the funnel graph. So you can see here at the right hand side, I have dragged and dropped this funnel graph out here, and it looks something like this. Now, in order to use funnel graph, we need to go ahead and have some different kind of data. So you can see here I have added one more field here called as status. This status says that this product has been dispatched, or this product has been delivered, or this product was refunded. So you can see that there is a status flag out here, which says things about this order actually, right? So what I would advise is go ahead and delete the current table, right? So from the SQL server, you can see here, you can go ahead and delete the current table and re-import the data. So go ahead and re-import the data, import flat file with the same table name, that is TBL customer. And I would also advise that go ahead and delete the model from here. So go ahead and delete the model from here, and then get the data from here, get the data from the SQL server, right? So you can see that I have gone ahead, I have imported the table back into my Power BI. So I would advise that go ahead, delete the table from SQL server, re-import it, go back to Power BI and delete the model, and again import the data out here, right? So now by doing that, then we can go ahead and see the output of funnel graph, because funnel graph needs a specified kind of data, right? It is not meant for general data. So funnel graph actually helps you to see the progressive reduction of data. Funnel graph actually helps you to see the progressive reduction of data. So for example, you can see here, I will now go and see take amount and take status, right? So you can see now I can see the progressive reduction of data. It says that amount of 27,000 was dispatched, right? From that 6,000 was delivered and 1,000 are refunds. So it tells me that how much total was dispatched, and how much is the delivered amount and the refunded, right? If you want, you can also go and add a measure. Like for example, I can go and I can add a measure here, which is like a count. So I can go and I can say here, how about first thing, let me go ahead and count the TBL status. So TBL status, right? So you can see here, this is the count of status, right? So let me go ahead and put here, let's again go ahead and put this funnel graph, right? And I will say that, okay, the values I will say is now count of status, right? So that this is like over here we have 100 data, and this is the status for the grouping, right? So now here you can see the um, exact values as well, right? So you can see I've created a measure here called as count. So we had 80 orders which are dispatched. From that, 16 have been delivered and 4 are refunded, right? So funnel graph actually helps you to see the progressive reduction of data. So that brings us to the end of this lab. In this lab, we have covered 5 components. We have covered line chart, we have covered area chart, we have covered stacked area chart, we have covered the gauge meter, and we have covered the funnel graph, right? So at end of this lab, I'm going to go and flash match the following question. So go ahead and try to answer the match the following question. From that, you will come to know which graph you should use on which occasion. Thank you so much. Keep learning, and we will keep doing lab 4, lab 5, and so on. Thank you. Welcome to Lab 4. This Lab 4 has 8 chapters, and in all these 8 chapters, my focus will be mainly on what kind of database design should a typical Power BI project have. If your DB design is not having the right architecture, then your reports would become tremendously slow as your data grows. So in this lesson, we will focus on 2 important designs. One is the star schema design and the other one is the snowflake design. But first, let us discuss the nature of Power BI data, and then we will check out what kind of DB design suits for the same. When we talk about Power BI helps us to show analysis data. So in other words, we would like to show aggregated data or summation kind of data or average kind of data. So we would like to show aggregated data. For example, you can see here product-wise sales. You can see here country-wise sales. But Power BI is not really meant to show individual records. For example, I don't want to go and see the individual customer entries. So this Power BI tool or visualization tool is more to show analysis data for the top management or for the mid management or for the sales or so on, right? Where they want to quickly get a picture that what is happening and what action to be taken. So we can say that the design needed for Power BI is more of an OLAP design, online analytical processing. OLAP kind of databases are those databases, wherein our goal is to go and select faster. We want to retrieve faster, right? So when you talk about Power BI, the backend design should be having an OLAP design. The other kind of database, we can term it as an OLTP database. In OLTP database, we have more actions related to insert, update, and delete. So we want to ensure that whatever data goes into the system, it should not be duplicate, it should not be redundant. So over there we follow normalized design, like first normal form or second normal form and third normal form and so on. While in case of an OLAP, we want to search faster. So here we follow more of denormalized design, wherein we try to club 2 tables and we want to put the data in only 1 table. So we want the selects to be faster. So when you talk about the nature of databases, there are 2 kinds. One is OLTP, one is OLAP. So in OLTP, we follow the normalization design, and in OLAP, we follow the denormalization design. In case you are new to first normal form, second normal form, and so on, I would suggest to go and watch the SQL Server videos where we have explained in more detail. But in this video, my goal is to talk about the denormalized design. So the first point is Power BI works on analysis data. So we need to ensure that our design follows the OLAP principles. The second thing is when you talk about analysis, at the center, it is the number. There is a number on which we do the analysis. For example, over here, we are talking about sales product-wise sales, product-wise, country-wise sales, country-wise population, region-wise population. So always in the center, there is always this number on which we want to do the forecasting, on which we want to do the analysis and so on, right? So there are 2 kinds of database design which is very prominent in OLAP. One is the star schema design and the other one is the snowflake design. So you can see here, I am on the Power BI database, and let me go and create a new database diagram. So I'm going to go and create a new database diagram, and let us go ahead and design a simple database which follows star schema and snowflake. Now in star schema design or snowflake design, there are two kinds of tables which are involved. One is the fact table and the other one is the dimension table. In the fact table, we put only numbers on which we want to forecast, numbers on which we want to do the analysis. And the dimension table talks more about the fact table. So if you see, for example, now let us say we want to create a sales OLAP, right? So I'm going to have on the center a fact sales table. In case you are new to SQL Server, in case you are new to these database diagrams, I would suggest to go and watch my SQL Server videos. So let's say that this is a sales table, wherein we have a sales ID, we will have a sales amount. So this fact table will have that numerical value on which we want to do the analysis, right? So you can see now this is the sales amount, but sales amount as per what? Like sales amount as per country, sales amount as per region, right? So the dimension table they talk more about the fact table. So for example, I can have a dim country out here, and this dim country will again have let's say an ID. It's always good to have a primary key in every table. And let's say here we have the country name, right? So now we want to say that, okay, this sales amount as per country. So what you will do now is you will have here a country ID underscore FK, a foreign key. So this is the primary key and this is the foreign key. So you can see here I'm dragging and dropping. So the primary key table is dim country and the foreign key is in the fact sales, right? So now over here, this dim country is the dimension table. In other words, it has the text, right, which talks more about the amount. So country wise sales. In the same way, I can have must be a new table here. Let's say a dim product, right, which again has a product ID as a primary key and a product name, right? And over here I will have product ID underscore FK. So this is the primary key table and this is the foreign key table, right? So you can see here now, this is called as the star schema design. In the star schema design, on the central, you have the fact sales table, wherein you have the numerical amount on which you want to do the prediction, on which you want to do the analysis. And then the dimension table actually more talk about that sales amount, right? So we can also think about that fact sales table is more about a numerical value. So they more talk about a numerical value, while the dimension table, they more talk about some textual value. Now, whenever you are designing the star schema design, right, ensure that you try to follow denormalization. Denormalization means we try to put as much as data as possible in a single table. For example, now, let us say that I want to get country-wise and states-wise the data. So country has states, right? So what I will do now is I will not go and create a separate dim states table, but what I will do is I will go and I will put the states ID out here. So you can see here the way I'm changing my design. So this is the country ID, states ID, states name, right? So I did not create, a different table, but I did it in the same table. And what I can do is I can create a joint primary key on the states and the country. So here now I can have the states ID underscore FK, no problem, right? And the relationship between these two primary keys will actually go to country ID as well as states ID. So I will say that, okay, this is a joint primary key and it should be mapped to the joint foreign keys out there, right? So you can see out here, I did not create a separate table called as dim states, right? So I do know that I will have duplicate data, but I'm fine with it because the more the tables I try to select from, the more my query will become slow. And the more I try to select from less amount of tables, I have less amount of joins and my select will be faster. So you can see my dim country is created, my dim product is created, right? So the dim product, is this table, dim country is this table, right? So all the things are created out here. So you can see one India, one of the province and the state is Punjab. In the same way for Nepal we have Godavari. In the same way again for India we have one more state here called as Maharashtra, right? Now you can see India and India is duplicate out here or redundant, but we have purposely done it so that we don't have to fetch from multiple tables and our query can be faster, right? So we understand it. So one of the issues, with redundant data is it is possible somebody can do like this, India 2, and somebody for Maharashtra can just say MH, right? Now this can create problems. You can see now you have redundant data here, duplicate data here, right? So what you can do in such kind of scenarios is you can go ahead and create a snowflake design. In a snowflake design, what people do is they actually, so in the snowflake design, right? So in the snowflake design, what we will do is my database diagram is not working. That's so sad. That's one of the bugs which we have in SQL Server. So in snowflake design, what we do is we create one more table called as dim states. So because of this redundant data, what you can do is you can go here and create one more table called as dim states with states ID, right? And states name, right? And I'll just say set it as primary key and I'll say dim states, right? And from this dim country, I will go and I will remove those two fields from out here, right? And I'll remove the fields from out here. So here I will now say, so this is country ID will be the primary key, right? But this dim states table, so the dim states table will have a reference of the country. So you can see here in the dim states table, I will go and I will refer a country ID underscore FK, right, on int. So I restarted my SQL Server Management Studio to just make sure that if we can make the diagrams working, and I can see that the diagrams are working. It is typical of Microsoft, they have these bugs, which are floating around. So you can see now what we are ending up here is that the dimension tables also have child tables attached to it. So you can see this country ID is now a foreign key out here, right? And over here we will have, okay, I did something wrong. Yeah, that's a foreign key out here. And the dim country will refer to the country ID only. And the dim states as well as will refer to the states ID underscore FK. So you can see now this is the snowflake design. In case of a snowflake, what happens is the dimension tables will again have relationships between them, right? Just let me make sure if this I have done properly. So country ID is here. Yeah, country ID, primary key, and foreign key country ID underscore FK. Okay, just wanted to make sure if I'm doing the right thing. So you can see now in star schema design, the dimension tables do not have further tables, right? In case of a snowflake design, the dimension tables have, further relationship as well, right? So now when to use star schema, when to use snowflake, it all depends actually. If you think that you want to make your query as fast as possible, then definitely I would say that stick to star schema design and do not worry about the duplicate data. Just try to make sure that you have proper data at place, right? But if you say like, no, like I'm getting a lot of redundant data, I want to just make sure that even the redundant data is resolved, right? Then you should actually then create this dim states table or a table which is having a foreign key. But please note that if you create more tables like this, you will end up into a normalized design, and then again it's possible that your queries can become slow because now you are selecting from a lot of tables, right? So this is the snowflake design, and we will stick to this for now. So you can see that I have inserted the data into the tables. You can see I have inserted data into dim product, product 1, product 2, in the states table, in the country table, in the states table. In the states table, we have to give the mapping between the country and states. I have done it. And in the fact sales table, I have made some data entry manually, right? So now let us go back to Power BI, and what we need to do to connect here. Now things become very easy because with this kind of design, wherein we have the fact table centrally and we have the dimension table surrounded, it becomes very easy to do visualization. So you can see here now, I'll just say Power BI, that's our database. And we want to select the dimension tables and we want to select the fact sales tables. Other tables are from the old exercise, so we'll just leave it. So if you see, once the data gets loaded, the first thing is internally also in Power BI, the model looks much better. So you can see here, these are our dimension tables and this is our fact table centrally, right? So this is the snowflake design. Why? Because the dimension tables also have relationships. So now with this kind of design, it is very easy to go ahead and create visualization, because now we can say, okay, let's say a stacked bar chart. So on what we want to do the visualization? Sales amount. So we select sales amount, and what is the dimension? So we can say, okay, we want country name as a dimension. We also want the product name as a dimension. So you can see now the way we do our visualization becomes more uniform and more standardized and more organized. And also definitely it is more efficient because this is a denormalized design, right? So the number of tables from where the query will fetch the data is very less. So whenever you talk about Power BI, at the end of the day, it is all meant for analysis. And for analysis, it is very important that we have either the snowflake design or either the star schema design. Now, this database structure, what I have here, right? What I'm doing is, when you're watching this video, I have given this database structure as a download in the .sql file. So you can see that you will see a file name as lab4 SQL structure. So, right. So you can go and you can download this file and you can open this file like this. So this will get opened into your SQL Server Management Studio, right? So it should get opened into SQL Management Studio. Oh, it's okay. It's opening into MySQL because I also have MySQL. So I want to open that file into SQL Server Management Studio. So in other words, let me just go ahead and drag and drop like this. So you will see something like this. And what you can do is, in order to just create the structure very easily, create a new database, like let's say new Power BI. And sorry for the spelling mistake. New Power BI, right? And then you can go here and run this script inside the new Power BI. You can see here I'm just saying new Power BI. So just run the script inside it. So if you say execute, you will see that in your new Power BI, all the tables will be created. So you can see here all the tables have been created. So you can get this file from this video download. So wherever you are seeing this video, you should see a download link. In case you don't get the link, you can please mail me at questmont@questmont.com. If you do not know how to create a database, you can mail me as well. I can probably help you out in more detail. So that brings us to the end of this video. After this video, I'm flashing some questions. Please try to answer those questions. So keep learning. Thank you very much. Welcome to Lab 5 DAX. DAX stands for Data Analysis Expression. DAX is a very important part in Power BI. So we will be having DAX lessons coming now and then in this tutorial. So this is part 1, which is introduction and warm up to get you ready and running quickly with DAX. So in this lesson, we will cover very important functions like filter, sum, sumx, calculate, all except, selected columns, joins, summarize, and so on. But before we start, let us first try to understand what exactly is DAX. DAX is a powerful combination of constants, operators, and functions. And by using DAX, we can go and we can create nice analytical data. So we have some data, and using that data we want to calculate average, we want to forecast, right? So basically this DAX expression actually works on the existing data and gives out more meaningful result, right? So if you see here, you can write DAX in two places. You can write DAX on a measure and you can write DAX on a column. So you can either create a measure or either you can create a calculated column. If you remember in the first lecture, I have already talked about measure and column, but let me quickly revise here. So for example, a measure is nothing but it is created on the table level, right? So it uses table level data to do analysis or to do calculations. So for example, I can go and I can create a new measure, right? So you can see I have selected fact customer. So on whichever table you want to create the measure, you need to go and select that table. So at this moment I have selected fact customer, and I will say this is a new measure. So the time I say a new measure, you can see that it has added a column out here called as measure, and you can go and you can expand this so that you can see things more clearly. So you can see that this is your DAX coding window. This is the DAX coding window. So over here I will say I want to go and I want to create a measure which is discount, right? Or let us say average. So average sales. So I'll say equal to, and you can see now we have some ready-made functions here. For example, average. So I can say average of the fact sales amount. So whenever this fact sales amount is referred, the total sum will be referred here. The total value will be referred here, right? So I'll just go and I will say this is done, right? So that's done out here, right? So you can see the average sales has been created. In the same way, you can go and you can also write DAX on a calculated column. So let's again select fact customer, and I will say I want to create a new calculated column. Always keep this expanded, because when you start writing big DAX expression, you need to really your code can become bigger, right? So over here I will say that we want to go and we want to create a column which is, let's say, discount, right? So I will say take the fact amount, fact sales amount, and I will say give a discount of, let's say, 50 rupees. So you can see now it is a combination of functions like average, count, max, and so on. It's a combination of operators like plus, minus, and it's a combination of constants, right? So this whole DAX is a combination of all these three things. So you can see now here, this is a calculated column. A calculated column applies more on a row level. So it uses the row level context. So you can see here now, for example, if you see, let's go here and let's select this discount. So if I select this discount out here, right, you can see now the calculated column works on a row level. So it takes 100 minus 50, 3000 minus 50, 900 minus 50, right? And while when we talk about the measure, it applies more on the table level. So for example, here I will say average sales. So look at it. The average sales here must be, I can make it a pie chart, right? So we can remove discount from here. It does not make sense to have a discount. So you can see average sales. Now this is more on the whole table level data, while this is more on the row level data. But whatever it is, at the end of the day, DAX expression is written either on a measure or either on a calculated column, and it is a combination of constants, it's a combination of functions and operators. If you want to clone a table, what you can do is you can click on this data tab out here and say new table, and then you can go and say, for example, let us say I want to go and clone the fact customer. So I'll say clone fact customer, and in the DAX I will just write here fact customer. So with this, what happens is, whatever is the table, it gets cloned here with a new name. Now, whatever changes you make into your fact customer table, all the changes will be updated to this clone as well. So if you go and if you do some changes in the formulas, or if you do some changes in the data, right, everything will be reflected in the clone fact customer. You can see at the right hand side, this is our fact customer and this is the clone of it, right? If you want to go and say, okay, while I clone it, I want to go and filter it. I want to say that filter, so clone the fact customer, but I just want to get the data which is product ID equal to 1. So I can go and I can say here fact customer where product ID is equal to 1, right? So you can see now the cloning has happened, but it has filtered on the value 1. One of the other interesting formulas, DAX formulas, is in BI, in Power BI, is the sum x, and the average x. So you can see here that I am on the product table at this moment. So this is the product table at this moment I am on. And let us go and create a column out here. So let us say that we want to go and create a column, where we want to go and display the total sales which has been done. So I'll say sum of fact sales amount, right? And by doing so, it just displays me the amount out here, and you can see that it is always the same thing. Why? Because it is just the sum on the sales amount. Please note that the fact customer is a different table. You can see fact customer is right out here. So from there, I'm pulling out the sales amount, and I'm putting it into the dim product out here, right? So this is the sum. So sum actually works on a field. But what if I want to go and use an expression? I want to go and say here, fact sales amount plus, let's say, fact sales average sales, or I want to go and put some expression out here, 10 plus, some 10% of it, like 10 divided by 100. I can't do it. And that's where the sum x comes into picture. Sum x actually helps you to do the total on an expression. So that's what that X stands for, expression. So let us go ahead here and let us again create a new column. So you can see here I'm creating a new column, and we'll say that this is a sum X, right? Or I'll say that this is sum X, and this is profit margin, right? Right, profit margin. So the profit margin is that whatever is the sum, right? Whatever is the sum at this moment. So the profit is almost 50%, or almost 50 rupees minus of it. So I'm going to say minus 50, right? So you can see here now I can't do this. So I will say sum x, right? Fact of sales amount, and then I will give the expression after this. So that's what the sum x comes into picture. So sum x, and what is the expression? The expression is sum x and table name, so fact customer, comma, and from the fact customer we want to take the sales amount and we want to minus 50 from it. So this tells me that this is the profit. So now what it will do is it will actually do the summation on this expression. So you can see that at this moment we have sales amount minus the constant. You can also go and use some other field, for example, minus the discount. Yes, that's also possible, right? So the expression can be comprising of field names and constants. So at this moment I'll just say 50 out here, and you can see now it is showing me the sum of the expression. So sum means sum only on the field value, and sum of the expression means it will take the expression and then do the summation on it. In the same way, we have average and average x as well. When you talk about DAX, there are two important technical vocabularies which needs to be understood. These two technical vocabularies are simple, but they need to be understood in a very proper way. The first one is termed as a row context, and the second one is termed as the filter context. So row context is nothing but, wherein your DAX expression goes row wise row, it goes through every row and evaluates the DAX expression. Means, for example, if you remember, we had created this discount column, right, in one of the previous video sections. And in this, we were saying that take the fact sales amount and subtract 10 from it, right? So over here now you can see that there is fact sales amount and it is minus 10. So what it will do now is it will take the first row 100 and say minus 10, and this is 90. Then it will take 3000 and minus 10 and it will take 2990, right? So basically it goes through every row and subtracts 10. So this is called as the row context. So that means that at this moment, this DAX expression has a row context. A filter context is nothing but, when you apply filters. In other words, for example, let us say that if you are on your Power BI screen and if you put a slicer, for example, if you go and if you put a simple slicer out here, so what will happen is this slicer will actually go and filter your values, right? So this is the filter context. Now filter context, can be at various levels. It can be on the UI where you put a slicer must be. It can also be in your DAX expression. For example, here probably you can have a column or a measure, where I will apply something called as filter. So filter can be inside the DAX expression, right? Or the filter context can be applied from the outside, from the UI itself, right? So there are two important things. One is the filter context and the other one is the row context. And the way the sequence works is, first the filter context gets applied. So the filter context, whatever it is inside the DAX query or from the visualization component of slicer, it gets applied, and then the row context gets applied. So for example, now if you see our fact sales table, so in the fact customer table, we have the sales amount, right? So for instance, when I go and pull up this table out here, and when I say I want to see the sales amount as per the product name, it shows like this. It shows that for product, this is 900. For product 1, this is this. Now, when I apply a slicer out here, let's also select something else. Let's select country name as well, right? So now when I go and apply a slicer, so for instance, let us say I take a slicer out here, and this slicer, I would apply it as per product name. So now what happens is, when I go and select product 2, only product 2 data is seen. And when I say product 1, only product 1 is seen. So first, your filter context gets applied, and then depending on the DAX query, the row context gets applied. Now, but there are some DAX expressions, which do not have any context. For example, let's take this dim product. For instance, you can see that I have this dim product out here. If you remember, just some minutes back, I have put up a sum here. Now you can see this sum is always 4,000 because this sum refers to the sales amount. So it's always 4,000. So if I go out here and if I say, okay, tell me how much is the product. So let's say I pull up the product name, and if I pull up sum, right, here it is, right? Now, irrespective whatever I select, it's always 4,000. For example, you can see here, if I see all of the values, it is 4,000. My slicer really does not have any effect on the value. In other words, in this case, there is no row context. The context is directly this sum out here. It just goes and says sum of that sales amount, which is but obvious, right? But now if you want, you can go ahead and attach in context here, because remember that there is a relationship between the product table and the fact customer. So if this relationship can be applied automatically, then that would be great, right? So for that, we have the calculate function. This calculate function helps us to override any kind of filter context which is applied, right? So at this moment, this expression is not having any context, but if I just go and put a calculate out here, look at this, look at the magic. So there it is. You can see now, the time I put a calculate, the calculate says, oh, first let me check, if there is any relationship between the product table and the fact table. And depending on that relationship, now you can see it is showing me the values that this is 3,100 of product 1 and there is 900 of product 2. So in other words, when you use calculate, it actually goes and overrides any kind of filter context which is applied at the top. So for example, I can also do like this. I can say here fact customer, and I will say the filter is that it's always product 1. So look at it. It's always product 1, right? Now with this, what happens is, irrespective what is the filter context, irrespective is there any relationship context, right? It will always go and use this dim product, right? So for instance, if I go to my board out here, and if I now take up this product name and if I use the sum, right? You can see now for product 2, he does not do any calculation. For product 1, he does the calculation. So you can see now, it is always calculating only for product 1 and not for product 2. So this filter context here, which is applied from the outside, does not affect. So let me just revise, what I've taught here in this past 1 or 2 minutes. First thing, there is a row context wherein the DAX expression will go row by row and apply the DAX formulas. There is a filter context, filter means, some kind of a filter which is applied from the external UI like the slicer, or must be what is applied from the from the DAX expression. So wherever the filter is applied, there's a filter context. The third point is, first the filter context get executed and then the row context is applied. The next point is that there is a relationship. So if you use things like calculate, the relationship will get used and the context will be applied as per the relationship. You can also use calculate to override any kind of filter context you have from outside. So if you want to just make sure that this expression is not applied, it is not affected by an external filter context, you can just put calculate and then apply whatever filter context out here, and this will ensure that it will only use the calculates filter context and nothing from outside, nothing from any DAX expression. There are two more DAX expressions, which I really like and I use it now and then. The first one is the all and the second one is the all except, right? So let's click on this new table out here. So this all, what it does is it gets all the records from that whatever table you specify. For example, you can see here I've specified here all fact customer. It has got all the columns of the fact customer as well as the rows, right? The second, what I can do is I can say, like I just want like few columns, from this table. So I can say, okay, give me all fact customer discount and give me all fact customer, let's say, the sales ID, right? So it just gives me those two columns, right? So the all has two variations. One is that you can just put the table name, it gives you all the records. The second is you can go and you can specify the column names. It will give you all the records, but only for those columns. Also, the other nice variation of this all is an all except. Herein what you can do is you can say, okay, I want to get all the records from this fact customer, but I just want to exclude, let's say, sales ID, right? So you can see that I'm excluding sales ID. So what it will do is it will get in all the fact customer columns with all the rows, but it will exclude the sales ID. Many times we want to go and select only the necessary columns from a table. For example, you can see here I have written a very simple DAX expression which actually goes and pulls up the whole fact customer, right? But now let us say I want to just go ahead and select the sales amount and I want to select the sales date. So what I can do is I can use something called as the select columns. So I can say select columns, take the fact customer. So the first column which I want is the sales amount. So this is the text which will be displayed on the grid, and I want to select the sales amount. The second one is the date. So this is again the text which has to be displayed, the column name externally, but internal column name is sales date. So you can see now by using the select column, I've selected only two columns from the fact customer. One is the sales amount and the other one is the sales date. Whenever we are dealing with data, one of the very important things which we always want to perform is joins. So inner join, left join, right join, and so on, right? So now let us say I want to go and join between the fact customer table and the dim product table, right? So for that we have something called as the natural inner join, right? So by using the natural inner join, I can say here natural inner join the fact customer with the dim product. So now you can see here wherever the product ID is matching with the fact customer, it has made a join. Now how does he know that he can make a join? Why? Because there is a relationship between the product table and the fact customer. So if you want to go and fetch the matching records between two tables, you can use this natural inner join. There is another variation to this also called as natural left outer join. So in natural left outer join, what it will do is it will go and fetch all the records from the fact customer table, irrespective they are matching or not matching, and from the dim product he will only select those values which are matching in the table. So if I go and make an enter here, you can see at this moment it is showing me 3 records, but if I press an enter, you can see now there are 4 records, right? So you can see that he has selected all the records from the fact customer. So for example, you can see that there is a record which does not have a product ID. Even that record he has selected, and only the matching records from the dim product table has been shown out here, right? So if you want to make a left join, you can use the natural left join. If you want to make an inner join, you can use the natural join as well, right? Also we have cross join, wherein it goes and it makes some Cartesian product. So it will take every record of the fact customer table and multiply it with a dim product table. So you can see here a Cartesian product actually takes every row of one table and makes a join with the other row table. So it's like a full Cartesian product between two tables, right? So natural inner join, natural left join, and cross join. But now, what if there is no join between tables? For example, now let us say I go and I delete this relationship out here. So with this, what will happen is, my formula of joins will stop working, because if you look at the natural, let's say inner join, it was using the relationship to understand the how to make a join, right? But now if I press enter, it will give me errors out here saying that it requires at least one common join column. So the natural inner join DAX function, what it does is it says that one is that you have a relationship, he can then figure out how to make a join, or even if the column names are same, he can still figure out. But here also, if you see here, the column names are also not same. So the master table has product ID and our transaction table has product ID underscore FK. So that's why it's, this join has not happened. So for this, we need to now go and write some extra code, right? So I'm going to go and expand this whole thing out here, and we need to go and write some, I'll not say complex DAX query, but a complex DAX code out here, right? So the first thing what we will do is we need to go and we need to define a key which is common between both of them, right? So let us go ahead and declare a variable. So you can see here I'm saying where this is the fact table, right? So we had a fact table. So if you want to declare a variable inside DAX expression, you can always say var and the name of the variable, right? So I'll say over here select columns. So select columns from the fact customer, and let's give a common name to them. So what we have to do now is, in order that the natural inner join works, we need to ensure that there is a common name between the columns, right? So I'm going to go and say that so we can say PID, that is the product ID. So over here we had fact customer product ID underscore FK, right? I'll go and declare a second variable which is for the product table, right? So product table, again I will say select columns, and here also what I will do is I will go and I will keep the same column name PID. So if I have the same column name, then the natural inner join can figure out what is the relationship, right? So this again here is dim product. So dim product and dim product ID, right? So both the names are same, and now I can say here where let us make a join, right? And what is a join? The join is between, so this is a natural inner join, so it's between the fact table and between the product table, right? So you can see now I'm using variables to define to make the join, right? So definitely this is not just variables, it is actually a table with selected columns, right? I can see some errors. Oh, it's a reserved keyword, fine. So I'll just say even this is the reserved keyword is not natural inner join. So what happened? So let's first thing, let's make this right. So I'll just say query, right? Fact, what is fact? Problem with fact, parameter is not correct. So let's see here, this is left table, this is the right table, but I can just say this is fact query, so that I'm not sure if really these names are reserved keyword, looks like product query. Let's put those words out here. I can see that fact is a reserved keyword, very strange, right? And now I'll go and I'll just say here return this query, right? So if I press enter, let's see what is down below. You can see down below there is an error out here. Look at this error. Can I copy this error? So you can see I've written the query, right? But I can see that there is an error here. It says that it does not support joins by using columns with different data types or lineage, right? Now what is this lineage out here? Now what happens is, whenever DAX tracks your table, right, or tracks a column. He tracks with a name. For example, here he knows that the name is product ID underscore FK. So here he knows that it is product ID from the dim product table. So even though if you have named it as PID, still he has a reference to this. So what we need to do is we need to go and disconnect that lineage, you know, what DAX has. So what we'll do here is we'll just go and say, okay, let's go ahead and disconnect the lineage by just adding a 0 out here. So with this, what happens is now the column names, the DAX will actually assume new column names, and it will actually then assume this PID as a column name, right? So I'll just press enter out here, and now you can see the output down below. So if I just go and scroll this, so that's the output. Definitely it's not giving out, it's only giving out the IDs, right, the matching IDs. What you can also do is you can say select columns. Let's add some more columns if you want to add here. Must be, I can add here, we can add, what do we have? We have amount, right? So I can just say fact sales amount, right? Okay, so there we have the amount as well, right? It's just matter of putting those column names, right? So remember that if you have a DAX expression which is trying to make a join between two tables, you know, who do not have a common column, then you need to go and use select columns and define a common column name and ensure that you take care of the lineage, you know, what DAX remembers. One more very much used function in DAX is the summarize. The summarize is used to go and do group by. So for example, now let us say I want to go and fire a DAX expression wherein I want to see the product and the total sales made for that product, right? The sum. So I can say summarize, and I can say, okay, I want to summarize on fact customer. What is the group by column? My group by column is the product ID. And what is the what you call the summary or the calculation which I want to do? I want to go and display the total amount and comma the sum of fact customer sales amount, right? And there it is. So you can see now I can see the product ID and I can see the total sales made for that product. You can also see that one of the entries is showing as nothing. Why? Because it's a null data. I have kept a null values also in the product ID. But now you can see that it is not displaying me the product name, right? So now what you can do is you can mix things like natural join, add columns, select columns, and so on, right? So actually, if I want to get the product ID, then I have to first do a natural inner join or natural left join between the fact customer table and between the dim product table, right? First thing. Always indent your code, so that is, so natural inner join, right? And then from here, from this natural inner join, on the top of it, I will go and I will say, okay, select columns. So don't take everything, you know. So select columns. Which one? I want to select columns, which is the first is I want to select the amount. So the amount is fact customer amount, right, from the fact customer sales amount from the fact customer table, and also we have the product name from the table here, right? So you can see this is a natural inner join. Now the output of the natural inner join is given to the select column. The select column's output will be now given to my summarize, right? So in summarize, what I will do is I will say, okay, summarize this. Okay, here it is. So I'll say summarize on what, like, so summarize on the P name. So this is the group by column, and I want to do a sum on the fact customer sales amount. You can see now parameter is not correct. Okay, and also we need to define a name out here. So the group by name. So I'll say sum per product, right, comma, so just enter. So that is, you can see the values out down below, You can see product 1, total amount, product 2, total amount, right? So remember, what I've done here, it is nothing but it is chaining of the DAX expression. So first I did a natural join. The output of the natural join is given to select columns. The select columns only send out two values, amount and product name, and then the summarize column actually did the summarizing or the group by on the product name, and we also need to go and specify the calculation for the group by, right? Very simple. So that brings us to the end of this lesson. So in the next lesson, we will take up other features of Power BI, but in between you will see DAX lessons coming up now and then. So that's why I've named this as part 1. And I will be adding more parts as we progress in the Power BI lessons. So as usual, we have some questions which are flashed up for revision from the revision perspective. Please try to complete the same. Thank you very much.